Aber ich denke, das ist
hat keine Bedeutung. Direkte Bedeutung.
Ausdenken. So kann ich es auch.
Weil die Wahrnehmung passiert.
We build mathematical models of the brain and the components, even nerve cells, synapses, connections between the nerve cells. And these models are very much simpler than the real neurons, of course, and components. But they are designed to capture the essence of the signal processing in the brain, let's say. The fantastic thing with the simulation of the brain compared to the real brain is you can get access to any data you want to have a look at.
My first sort of reflex as a sound artist to use data to sort of engage with data is to listen to it. So I turn it into sound, and my reflex is to do that as directly as possible. The check field is experienced by putting up this headphone and just plugging the headphone in different checks. That's the name. And this is our kind of terminology, our slang for this device. It uses the output of a simulation of about these 2,500 nerve cells, and the kind of data we got from the simulation was, on the one hand, the spikes data you mentioned. So when a nerve cell actually produced the spike that connects to other nerve cells, but they were also used the potential data of each individual cell. But then one of the cells might decide to spike. And this is something that you can hear. What you hear here, I think, one could describe as some low sounds and some high sounds. You heard these spikes, right? These very bright sounds. These are actually the spikes of the neurons, and these low things, these are the potentials of the nerve cells.
If you have 2,000 cells and organized in some way, maybe in clusters, small clusters of 30 cells, which it actually was, so you get 81 of those, which represent the point. And then you can look at the correlations, measure those, and build forces from those.
This system tries to negotiate different forces, and that's also something you can see and can actually feel when you look at that. There are points that are pushing around, and sometimes a point goes like...
It is already a very complex system, and complexity means that you have non-univoc solutions, right? And that means also that you cannot go forward and backward in time and hope to find the same solutions.
As the system works, going backward isn't like a video where you go backwards and you go to, second one of the video and you see what's second one. If you go forward and backward, you're not again where you were earlier, because the system has moved and is moving forward, backward with you. The system, cannot be controlled in the same ways that I'm used to control footage. Video footage or any other footage. It's quite stubborn, and in a way, once you break it by interference, you can't undo it. It's kind of part of it. So very hard to actually get somewhere where you want it to go. You have to gently kind of move along and then remember your move and kind of repeat it slightly differently. And it's a very different working base. To force yourself not to control, to kind of get out of this one-to-one relationship, those systems allow us to step back from the need to represent, because in a way they approximate. They will never really fit the data. Like 2 dimensions will never represent 81 dimensions.
traces produced in an experiment are usually of a volatile character. In order to work with them in what could be called a data space, they have to be made durable. So you see, I'm dealing with data not as the primary material of the science, but as an already transposed material. A typical example is the transposition of a molecular DNA sequence gel into a chain of symbols. A, C, T, G, standing for the 4 building blocks of DNA. Total abstraction is made not only from the virus, from which the nucleic acid was extracted, but also from the test tube reaction in which it was differentially synthesized in order to create these traces here. We could even say no trace is left from these traces.
It's a very thin fiber, extremely thin, and it's 2 meters long for the human. And the challenge for the cell is to put this 2 meter long molecule into this little tiny cells. You know how little the cells are? So the genome structures itself to bring certain molecules in the DNA close to each other. Okay? So it makes loops. It makes these thousands of loops, like this is a loop. And then this is another loop, and then this is another loop. Why our genome is 2 meters long? You know, why the cell need that long molecule? It's certainly not because the humans are very complex, because, for example, the fruit fly has 5 times more DNA than us. The proteins that are doing all the work, like the synapses, they actually are comprising less than 2% of the genome. The 98% is actually regulating which protein is going to be present in which cell. And that's is enabled by making these loops. So if this is the gene, and this is the other region that is deciding which cell this gene or this protein is going to be expressed or is going to be present, then these two together, and then they communicate, and then they say, okay, you know, I let you to be present in the cell.
What Pelin talked about earlier in terms of these loops, when it's pictured, it's a static state from which the data derives. And if we try to model it through a dynamic system that David built, so we're trying to take a string with loads of hinges and model it to get the interactions right where they're supposed to be, it's virtually impossible without breaking it at some point. So what you see here in these lines, these are not the lines of the DNA strand. These are, in a way, the interactions that could not be reduced to 0. It's a distance our model still has to deal with. So you can imagine that if we were perfect, there would be no drawing, because everything would be collapsing onto a meeting point. This is an impossible object in some sense. I mean, it's an object that doesn't exist like this.
Models can be addressed as data clusters or data assemblies, as data wholes. What they basically allow one to do is to overview at one glance a multiplicity of data in connection with each other. They thus create the illusion to see the whole. And even if this is an illusion, the reason to proceed in this way is precisely to create or to uphold this illusion, which gratifies our intelligence and our sensibility with a pleasure that on this basis alone can already be called aesthetic.
This isn't true. Even though it looks true, it has all the lines, because obviously these lines are made from when they were decontaminating the space. So the whole R1 space has these lines and numbers, so they know they've done that meter square. And obviously we collected as much information out on the internet as possible, but actually the R1 has a huge amount of data out there. The thing about data is we are saturated in it. It's our ability to find it. But for us as artists, I think we're also interested in the failure of what that can be and how it is we accept it as some sort of truth because we're all lazy, we accept what we see. And so that's why we wanted to glamorize in the site this almost fabricated, untrue, but we would read it straight away that it was what wasn't there. And we wanted to bring that to the space.
Right in front of the Royal College of Music at Stop Stadium take the Tunnelbana subway line 14 red line towards Vienna or Moscow. Get off at Lilienholmen 8. Stop after 14 minutes. Turn right when leaving the train, take the escalator upstairs, and take a right again after the turnstile towards the exit Trekanten. Walk down the glass staircase and cross the park, Trekantsparken, on the gravel walkway towards the north. At the end of the path, take a slight right. Note the sign indicating the way to Werkfabriken at the brown wooden wall of a factory building. The sign leads you down Trekantswegen, which you follow, crossing Löfholmswegen, the biggest street with tram tracks, until you arrive at the next crossing with Löfholmsgränd, where you turn left. From the corner you can already see Werkfabriken, at the far end a red brick factory building between two brick smokestacks, the left smaller one belonging to Werkfabriken. Follow Löfholmsgränd until it branches with a slight right into Löfholmsbrinken. At the end of the street you enter the parking space of Werkfabriken and walk along the right side of the building towards its entrance on the other side. It will have taken you less than 10 minutes from the Lilienholmen Tunnelbana stop.
So this is a sonification of galaxy cluster data. I have tried to work with parameters that make sense musically. So I like the fact that the term cluster is also a musical term. A focus in my work is computational intelligence and machine listening. I'm usually working on compositions for acoustic instruments and intelligent computer systems, in which both the musician and the computer system have to listen to each other and react to each other's actions. So I am trying to create a reciprocal interaction between the human and the machine that are involved. I'm interested in exploring these possibilities that go beyond human listening, because the computer can analyze a signal and extract information from a signal that the human ear can note.
But what remains that is not linked to data? What is he calls it the language of the beats of the body, that is transhistorical and not linked, not hinged to a particular code.
Guest coming to the symposium, where to start with you don't quite know what the program is. Secondly, you don't really know what to expect when. I mean, the attempt is to increase the kind of the cloud of dots that are floating in any of these systems. To start with a certain destabilization, with a certain making things move.
I was wondering what's the role of the data set? Is it inspiration? You know, it could be random clouds of data driving the whole thing. We wouldn't know.
I would say that if you go through the show, but also if you look at the data, it cannot be random. There are structures and redundancies in the data that give it a certain character. And what's also in the data is the thinking space within which it's being created. So it's formatted in particular technical ways, but it's also formatted in particular social cultural ways.